Here it says the graph shows Blair's distance from home on a 6-hour train trip. During which of the following time intervals was her average speed in miles per hour the greatest? So we need to remember that speed is your rate of change. And rate of change is the same as slope. So if you're given a graph here, we can find the slope of each of those segments. So slope is the change in y, so the change in miles in this case, divided by the change in x. So let's find the slope of each of these segments. So from here to here, what is the change in miles? I went from 0 to about 50. So I went 50 miles. And what's the change in hours from 0 to 1? So in 1 hour, 50 miles. So 50 miles per 1 hour. That is my rate of change, my speed. Let's do another. How about this one here? So this one went from 50 to 120. So let's just subtract those and see we went 70 miles. And then what's the change in hours? 1 again. So 70 miles per hour. So I went ahead and calculated the rate for each of the other segments, but how about this yellow segment? Remember, if you have a flat line like this, a horizontal line, there's no slope, there's no rate. So let's think about what that means. What's the change in miles? I stayed there at 160, so it's a 0 change in miles in 1 hour, so 0 miles per hour. So doing this is one way you can solve this problem, and you can very clearly see where we had the highest rate. It's right here, the blue line, so it's between time 4 and 5. But you didn't actually have to go through and calculate the rate. Just looking at the graph, we could have figured this out. The one with the highest rate has the steepest line. Notice that that blue line is the steepest. The ones that are the flattest, like the yellow and the green, those have the smallest rate.